It's all about the moles. It's all about the moles. It's all about the moles. That is the mantra that should be going through your mind anytime you see this sort of question. So here are three of the typical sorts of questions involving the Avogadro constant and moles in the GCSE Chemistry exam. The first question: magnesium nitrate decomposes when heated to form magnesium oxide. Then underneath there is the balanced equation. Calculate how many molecules of nitrogen dioxide, NO2, are produced from 0.45 moles of magnesium nitrate. The Avogadro constant is 6.02 times 10 to the 23. Give your answer to three significant figures. So the most important piece of information in the question is that you have 0.45 moles of magnesium nitrate. And they want you to find out how many molecules of nitrogen dioxide you get from that many moles of magnesium nitrate. So the first thing to do is look at the ratio in the balanced equation between magnesium nitrate and nitrogen dioxide. So the ratio of MgNO3 twice to NO2 is 2 to 4. This simplifies to 1 to 2. Therefore, if you have 0.45 moles of magnesium nitrate, that would produce 0.9 moles of nitrogen dioxide, because 0.45 times 2 is 0.9. And then, using the Avogadro constant, you know that 1 mole contains 6.02 times 10 to the 23 particles. And those particles can be atoms, molecules, or ions. In this case, it's molecules. So if 1 mole would contain 6.02 times 10 to the 23 molecules, then 0.9 moles would contain 0.9 multiplied by 6.02 times 10 to the 23 NO2 molecules. And then putting that in the calculator, 0.9 times 6.02 times 10 to the power 23 equals 5.418 times 10 to the 23, which to three significant figures, as they asked in the question, is 5.42 times 10 to the 23 nitrogen dioxide molecules. Second question. Calculate the mass in grams of a hydrogen atom using the data below. Relative atomic mass of hydrogen is 1. The Avogadro constant is 6.02 times 10 to the 23. So the Avogadro constant, that tells you that 1 mole, in this case, of hydrogen atoms contains 6.02 times 10 to the 23 hydrogen atoms. The key point to answering this question is knowing that 1 mole of any substance weighs its RFM, or relative formula mass, in grams. So this means 1 mole of hydrogen atoms weighs its relative formula mass, which is 1.00 grams. So if 1 mole of hydrogen atoms contains 6.02 times 10 to the 23 atoms, and 1 mole of hydrogen atoms weighs 1 gram, then the mass of one of those hydrogen atoms, so mass of one hydrogen atom equals 1 gram divided by the total number of all of those atoms that are in 1 mole. And putting that in the calculator. So 1 divided by 6.02 times 10 to the power 23 equals 1.66 times 10 to the minus 24 grams. Next question. The formula of aluminium sulfate is Al2SO43. Calculate the total number of atoms that combine to form 5.13 grams of aluminium sulfate. And then you have all the relative atomic masses underneath and the Avogadro number. This is a 4-marker. So again, always with these questions, remember to show all of your working to get all of the credit. You could punch in the answer in a calculator and even if you get the correct answer and write that down, you won't get much of the credit because you always have to show your marking to get all of the marks. So, calculate the total number of atoms that combine to form 5.13 grams of aluminium sulfate. Remember that mantra? It's all about the moles. It's all about the moles. So the first thing you need to do is convert 5.13 grams of aluminium sulfate into number of moles of aluminium sulfate. And that is using the equation N, the number of moles, equals the mass of the substance you have in grams divided by the relative formula mass of that substance. So in this case, number of moles of aluminium sulfate equals 5.13 grams over the RFM of aluminium sulfate, and that is Al2, so it's 27 times 2 atoms of aluminium, plus SO43. So that means you have 3 atoms of sulfur, so it's 3 multiplied by 32, the relative atomic mass of sulfur, plus oxygen atoms. You have 4 of them in the SO4 group, but you have 3 of these SO4 groups altogether. So that means you have 4 multiplied by 3, which equals 12 atoms of oxygen. So that is plus 12 multiplied by the relative atomic mass of oxygen, which is 16. Brackets, put this in the calculator. So moles equals 5.13 divided by 27 times 2 plus 3 times 32 plus 12 times 16, close brackets, equals 0.015. So 0.015 moles of aluminium sulfate. And we need to calculate the total number of atoms that are in 5.13 grams of aluminium sulfate. Okay, so for this, the formula of aluminium sulfate is Al2SO4 3. So the Avogadro number, or constant, tells you that 1 mole of this, 1 mole of aluminium sulfate would contain 6.02 times 10 to the 23 formula units or lots of Al2SO43. But that doesn't tell you how many atoms there are in total. So if you consider one formula unit of aluminium sulfate, that contains 2. So one formula unit of Al2SO43 contains 2 atoms of aluminium plus 3 atoms of sulfur plus 12 atoms of oxygen, which equals 17 atoms in total. If we had 1 mole of Al2SO43, that contains 6.02 times 10 to the 23 lots of this. But in terms of atoms, it contains 17 multiplied by 6.02 times 10 to the 23. So that's how many atoms you would have in 1 mole of aluminium sulfate. But in this case, we have 0.015 moles. So the number of atoms in 5.13 grams equals 0.015 moles multiplied by 17 atoms in each formula unit of aluminium sulfate multiplied by 6.02 times 10 to the 23, which is the Avogadro number. And then putting all of those into the calculator, 0.015 times 17 times 6.02 times 10 to the power 23, which is 1.5351 times 10 to the 23, or 1.54 times 10 to the 23 to 3 significant figures. So I hope you found this helpful. And if you did, then please like and subscribe, and I'll see you at the next one.